Case number 18. Let's check or verify this given identity. We have here the ratio of cotangent alpha and cosine alpha, which is equal to cosecant alpha. To verify or check this identity, we need to make sure that both sides of the equation will have the same identity or they will have an equality here. To do that, let's pick a side, in this case left-hand side, to manipulate in such a way that the ratio of cotangent alpha and cosine alpha will be equal to the right-hand side, which is cosecant alpha. In cases wherein both sides of the equation are a little bit complicated, we are going to manipulate both of them. But since our right-hand side is already cosecant alpha, let's stick with it. To manipulate our left-hand side, we are going to express the identities in terms of sine, cosine, or a combination of both. Since our denominator is already cosine alpha, let's stay as cosine alpha. But our numerator of cotangent alpha will be represented by this. It's actually equal to cosine alpha over sine alpha. This is the equivalent identity for cotangent alpha. Okay, we have cosine over sine. But this is just the numerator. Our denominator will be still cosine alpha. Now from here, we are going to make sure this is equal to our right-hand side, which is cosecant alpha. Because our goal is to come up with an equality as soon as we move from steps to steps. So we need to make sure that this is equal. But of course, since this is a little bit complicated, let's write cosecant alpha later, since we can now simplify this further. We are going to use here the concept of keep, change, flip method. This because we are actually dividing rational expressions here. Our numerator now is originally cotangent alpha, but now it becomes cosine alpha over sine alpha, a fraction, or in this case, a rational expression. Our numerator is cosine alpha, but this could also be written as cosine alpha over 1. Now we are dividing two rational expressions, or similar to dividing two fractions. We can use here the keep, change, flip method in such a way that instead of dividing them, we are going to multiply them. So the keep, change, flip method follows this. You keep the numerator, the entire numerator. So you have here the same cotangent alpha represented by cosine over sine. Okay, we're going to keep it as it is. Then change the operation of division into multiplication. So keep, change, and then we flip our divisor or our denominator. Flipping means we are going to give its reciprocal. So the reciprocal is 1 over cosine alpha. Okay, so this is what happens with keep. We keep the first the first rational expression or the numerator or the dividend. The operation becomes multiplication, and our divisor or our denominator here becomes its reciprocal. Of course, we can now write here its equivalent, as this is equal to cosecant alpha as given already here. Now, let's try to see if this entire expression really equates to a cosecant alpha. Now, you can multiply here numerator to numerator and denominator to denominator since you are multiplying two rational expressions now, or simply apply here the cancellation law for multiplication. We have cosine alpha here, we also have a cosine alpha, so what remains here is 1 over sine alpha, because our numerator will have 1, our denominator will just have sine alpha, and this is equal to cosecant alpha. Even if it's too obvious, the goal for checking or verifying identity is to make sure that both sides of the equation will have the same identity. So let's not stop here, let's continue. We know that 1 over sine alpha is actually equal to cosecant alpha, and of course the right hand side is already a cosecant alpha. Once you reach this point, you have now verified or checked this given identity, saying that the ratio of cotangent alpha and cosine alpha is equal to cosecant alpha. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.